So let me do this. I'm going to put it back on speaker mode, and I'm going to allow participants to unmute themselves. Again, if you want to ask questions, you can do Option Y on Mac or Alt Y on Windows. I'm going to paste that into chat right now for you. And anybody who has questions for Detlef Hoyer, please raise your hand. Again, Option Y on Mac or Alt Y on Windows. It's a little easier to do it that way. So, and we'll give it just a sec because you went through so many different aspects of it. Okay, and I'm also going to scroll through chat here real quick. Okay. Let me see. Let me start with Dr. Andis Dembowskis.
Hello. Just a quick question. Yeah, greetings from France. Can you say, like, you have investigated in depth, especially the physics, much appreciated. Could you tell, like, references to other works who have tried to replicate the effect and how far they have gotten? So I understand you more dive into physics and theory, but could you shed some light on possible replications and how far they have gotten of the work? Thank you.
Yes, I showed the book, and there are several versions of the Kaluza theory. Kaluza himself put the kappa to a constant, which separates gravity and electromagnetism completely, as we know it. But when this kappa is varying, and also the other potentials, then there are a lot more of free parameters. But this may not cause any new effect, except the 4D space depends on the fifth dimension. So which means this shrinking or widening of the metric in 5D space, the 4D brane in the 5D space. And in the book it says it's dependence on the fifth dimension is necessary. Then there is a new effect, a new force. And a new force means we know the Lorentz force for an electron in magnetic field. It's the three-finger rule: magnetic velocity, magnetic field, and effect. So the force is always orthogonal to the velocity and will not change the velocity only in direction. Not the particle don't get faster or slower. And the theory predicts a component in the direction of the velocity. So the charge can be accelerated or slowed down. But this force only occurs when this scaling appears, and I don't know how this can be done. How do we change the cosmological constant locally? I don't know. So this is a difficulty. The formulas are unknown, but yeah, perhaps it's only energy. You need to have high energy density within the small volume. Perhaps that changes the cosmological constant. There is a difference between the cosmological constant in astronomy, which is very small, and in particle physics, it's ultra high. And this is an unknown or not a solved question why this is so. And perhaps it's only necessary to achieve high energy densities. one possibility.
Okay, thank you.
And thank you as well. Let me go to Harold next. Sir?
Oh, Dr. Detlef, thank you. You never disappoint. Great presentation, the part that I saw.
There's no.
So use this, you know.
Your picture is frozen.
Oh,
But
the
we hear you.
field energy effect and gravity. As a localized event in a space-time, can you treat, you know, for example, that the localized, the field effect that we see on gravity is basically, can we treat it as a sum of the, for example, electromagnetic energy, the effect on nearby matter by the electric field, the magnetic field, in addition to gravity, and how would that be reflected, let's say, in a fifth dimensional space-time configuration?
For gravity, only the mass density is a source for gravity, where the energy stress tensor is different from zero. It's only the region where the mass is, and outside the body there is no energy and no energy tensor different from zero. So the gravitational field has no energy. And the 5-tree electromagnetism shows the same feature. All points where the stress energy tensor is different from zero are inside the body, and it comes from mass and charge inside the body, and outside the field energy is zero. But there is pressure which causes the forces. So 5D electromagnetism is like 4D gravity. So you asked difference. Yeah. In 5D, there was no energy momentum stress tensor. It's always taken the Einstein tensor in 5D is set to zero. And all singularities in 4D are generated by curvature in 5D. And we know it from the Campbell theorem, so that a space with singularities can be transformed into a space without singularities when you increase the dimension by 1. So in 5D, there are no sources needed. And we saw in the metric tensor that the corner value was non-zero and depend on the charge. And this is the component of time in the fifth dimension. So charge is a mass moving in the fifth dimension. So we saw in the vector which had components in t direction and in L direction. So if the charge stays at the same point and doesn't move in the fifth dimension, then there's no charge, only mass.
Okay, one more question. In your conclusion, number one, you bring the effect of the electromagnetic field and gravity. There's a relationship. And
Yes.
the question I asked, you know, that I just finished asking, if an observer story, let's say, to two bodies interacting with each other let's say, you have a space-time, a volume of a space in which the mass, for example, of the body that is intact, second body, one of them, but the first body, let's say, has a content of electromagnetic, in terms of electric field and magnetic field energy and gravity. Now, all those three are acting as if it were a propulsion, force that is pulling one body toward the other. Now, my question on that one is, if that can be treated, for example, a vector sum of kinetic energy and potential energy and gravity, does have any effect, you said on your conclusion on number 6, that variation in the 5th dimension will cause a new force. And you pointed like lift, for example. I'm looking from the viewpoint of an engineer trying to using that theory, those principles to engineer, let's say, a device. Now, can you give me an example of concrete example or something that illuminate that point, the variation on the 5th dimension will cause, the force of lift or proportion, from what you have there, because look like all that you have written from the previous presentation point that way, but now we have to reduce it to the engineering. Can you give us an example, a clue or something that we can drive that way and find something there?
Yes. One is, I said, when the gravity constant varies around the mass, then it could show up as a variation in particle mass. So if you have a mass moving, its momentum is mass times velocity. It's a momentum. And if we have momentum conservation and are able to reduce the mass of the body, and the momentum has to be conservated, then the velocity has to increase. So if we manage to reduce the effective mass of a particle, then its velocity has to increase to so that we get the same momentum. So, but the particle mass can only be changed if we are able to cause changes in the 5th dimension, whatever that means. But that would be the result. What the equations say. Perhaps imagine an electromagnetic field around a machine or a vehicle, and it moves, and when you put the electromagnetic field into action, the mass of the vehicle reduces, and the momentum must be conservated, so it accelerates.
On that tone, concept, for example, a new force, how we look in the space that momentum is conserved, taking into account the 5th dimension, 4th dimension. So the situation that it looks like a perpetual motion machine or a violation of conservation of energy and momentum. How one reconcile those calculations, those possibilities, the one, because immediately the moment that it becomes conservation of energy and momentum, everything is dismissed, thrown away. So how do you reconcile that? Can you point in your equations where one can reconcile all that, take into account that one can conserve the other.
Yes, I don't have this equation in my slides, but I had it in the previous presentation. I can look it up. One point is you have the.
You point out preserve conservation of momentum, since on the fifth dimension, it will produce a new forces. How we can reconcile with conservation of energy and momentum, because you're pointing out basically from the engineering viewpoint, if I look at everything you say, I can summarize it saying, okay, in order to affect, produce effect in the fifth dimension and, for example, and create something, a new force, one would have to say, use electromagnetic, basically electromagnetic energy, manipulated in creating a device that will use energy to produce a proportion for 6. And number 2, looks like conservation that is an exchange between kinetic and potential energy, in simple terms. Number 2, agree with that number you point. So how can the idea, have you done any, because it seems to me like it's a wide open a bit, because all the things that you have is so complex that one has to navigate to find, a lot of searching in order to make sure that everything from the fifth dimension using that will reconcile with conservation of momentum, conservation of energy, and would not look like a perpetual machine or a violation of laws. Because, for example, in your previous presentation, you have this diagram where you present the fifth dimension.
Sorry, I don't hear anything.
Yeah, sorry, Harold's connection is kind of going in and out. I'm just giving him a minute there. Wait. Okay, you know what? I think that we've lost Harold. So let's do this. Let's see if we can take. Oh, there's another question. John, welcome, sir. Go ahead.
Hi, I don't know if I'm muted. Okay, I think I'm sending audio. Hope everyone can hear me. Thanks to our speaker.
You look and sound great, sir.
Thank you so much. I do get some interference here, so I apologize in advance. It's a very thought-provoking talk. I have a couple questions, one kind of pedantic question, and then maybe a more substantive attempt at a contribution. There was a slide where you showed the Einstein tensor, you showed the stress energy momentum tensor. Those were in different dimensions. Was that stress energy, I think that's maybe because that stress energy momentum tensor resided on the forebrain, on the 5D kind of bulk. Is that what was going on there?
I took there the Minkowski metric, which is 4 times 4 matrix with ones, and at the edges were the electromagnetic properties. And if we take the Einstein tensor of this metric, we also get a 5 times 5 matrix. And I showed only the 4 times 4 part of it. There are other components, but I don't know what they mean. And I left them out.
Thank you, thank you. I thought as much. I appreciate that. And as far as, there's an earlier slide where it seems that these metrics, not using outside theories of general relativity and other articles we may have read, but just internally to your discussion, it looks like these metrics are defined with a constant curvature hypothesis. And due to isotropy on a cosmological scale, this is fine on a cosmic scale. But when we attempt, this is my suggestion, I think you said that it's still kind of open research to apply this in the material realm to some of the, I don't know how authoritative these observations are, but when we want to go to the meso scale, I don't think we have the assumption of constant curvature. So you could use a renormalization group, I might suggest, or you could use, you could maybe go into a more speculative approach of kind of a quantum gravity, where you could take tensor products of metrics. What this will give you something more valid in that mesoscale regime. This would look more like theories of emergent gravity. And they've had some successes with those kind of entropy driven techniques in things like superconductivity and just generally things in that mesoscale. So that's just an attempt to try to inform an approach that might bring this in more into the regime of material science, and that would not you may lose the 5 dimensions. You may not be in as high of dimensions, but our study of you know, things like differential topology and higher dimensional mathematics, this is okay as we are kind of going down the ladder of length scales. I think there's reason for this. So for example, in a black hole, now that's a little bit larger, but you would use a Schwarzschild metric, which pretty much works in 4 dimensions, explains a lot about causal horizons and things like that. Just some ideas that might work here. Oh.
First here is for your first question. On the upper left, the metric Minkowski space plus Coulomb potential and the kappa. And below you see the Einstein tensor. And the first 4 rows and columns represent the energy mass tensor of electromagnetism. And there are other components in the 5th row and 5th column, but I left them out. These are the equations from the question before. On the left side is the geodesic motion. You know, the Newton's equation, force is mass times acceleration. And when there's no force, there's only, so there is a free fall. And free fall is the geodesic equation. And here we get derivations from the 5th dimension. So the 2nd row shows that on the left side is the normal geodesic motion, but because of the additional term, it's not 0, but it's non-zero, and there's a force, which here is called F mu. This is from the book, and it has a component parallel to the 4D velocity and the component orthogonal to the 4D velocity. And it would mean that here the force is not always normal, the green force, but there can also be a component parallel. So that would be the outcome of the theory. And go back to the solution. Oh, just a moment here. This is the solution of a charge mass, describing the gravity field, the electric field, and the magnetic field is 0 here. So we had to make a Lorentz transformation. And for zero charge, we get here the metric of a black hole, Schwarzschild metric. So this is in the universe included. So we don't have not only dust in the universe, we have also black holes. So it's a very idealistic model, the Robertson-Borger-Friedman model. It's very idealistic. So
just to reiterate, though, I think you can get away with that on cosmic scales. As you want to apply, say you want to apply techniques of general relativity to understanding the disruption of matter that we seem to see in Hutchison, I think that you will have to use a metric that do not have constant curvature.
oh, yes. But perhaps it's possible to have a variation of the cosmological constant, and that may cause a motion of the 4D brain in the 5th dimension. And if we have in different locations different variation, so the crystals of a metal may be affected by this, or the electron orbits. So they leave the crystal and build a fluid because of this variation in the 5th dimension, or the wobbling of the different parts of the 4D membrane. So
wonderful. Okay, so let me jump in real quick. John, thank you so much for your question, sir. Let me jump in real quick, and again, remind everybody that you can do Option Y on Mac or Alt Y on Windows. You can do that to raise your hand there. Let me see, Rob mentioned, and he was answering a question from Dr. Benkovis. Rob mentioned he didn't think there have been any successful replications of the Hutchison effect. That, as someone who studied it, I would echo the same. I think there are lots of things from other people that folks have looked at and said, I think this is the Hutchison effect, but to my knowledge, there's never been an official replication that's produced any results. So, you know, but again, that would be Alt Y on Windows, or sorry, Option Y on Mac or Alt Y on Windows. You can also type those questions in the chat. We've got just about half an hour left in the Q&A session. Again, I want to thank Detlef for joining us. And I would say, you know, whatever questions that you might have about this, about how Kaluza-Klein theory or 5D brains, things along those lines might possibly create these Hutchison effect levitations, you know, fire away, fire away.
Yes, I talked about the electromagnetic energy, which may is the source for scalar waves or scalarons. And the Tesla coils have a certain frequency, so there's only one frequency in the field. And if you have a Van der Graaf, this is a spark gap. The spark generates a broadband frequency signal. So it's very different putting energy into the space. And so also a knife, so the knife has another resonance frequency than the metal bar. So they may take different amounts of energy because of different resonance frequencies, and maybe on different levels. for in different 4G brane levels and move into one another. That was what I'm thinking about. And these Scala-Ron clouds may cause a variation in the fifth dimension and cause these forces.
Yeah, and then let me see. John is mentioning in chat. John, you were asking how the Hutchison effect differs from diamagnetism or levitating frogs, Chinese new anti-gravity chamber. I would say this is. I would say in all of those they have very heavy-duty magnets, right? And they're using some kind of a magnetic alignment, paramagnetism, something like along those lines. The Hutchison effect seems to happen. He's had lots of stuff like samples that he would put on a table with no large magnets and no high voltage equipment near them, right? And he would still get these effects. So I think that's probably the best way to describe it. They're definitely something different than the levitating frogs, so. Well, again, guys, option Y on Windows or option Y on Mac or Alt Y on Windows if you have questions. Jeremy Reese, I should ask, do you have any questions from the YouTube stream that Detlef could answer? Okay, I'm not seeing any movement from Jeremy, so. Okay, well, I'll give it one more moment and then we could, if you guys like, we could do kind of an open discussion thing. So our next speaker is Kevin Day, who's going to be in about half an hour. Or Detlef, if you have more that you would like to share, that's also completely cool.
Yes, it's all 5D electromagnetism stuff, and
yeah, if you'd like to, if you want to do background info, that's if you're open to it, and if not, I don't want to pressure you. Again, I want to thank you for your presentation.
In the last presentation in the summer last year, I made some statements about the book of Paul Hill, Unconventional Flying Objects. The solution which he gives is either a new force or a reduction of particle mass. So these all are effects which have no explanation yet. And I see some similar effects in the 5D electric theory. Yeah,
oh,
and then I had another point, but just a moment.
Okay, I'm also wondering, do you think you might be able to upload your slide presentation?
Yes,
if possible. Todd was asking about that.
I will do it. One PDF with the conclusion and one PDF with the whole slides.
Yeah, and then Harold Tavares was actually asking if the Hutchison effect qualifies as a new force or energy or something else. Oh, Harold was asking if the Hutchison effect qualifies as a new force or something else. That's kind of a vague question. I would say probably. I would say not a fundamental force though, right?
Yeah.
Yeah.
Recently, I saw a video where not only lifting was shown, but also a pull on the table from right to left, and then lifting began. So it's not anti-gravity. It's a new force. We don't know yet.
Yeah, absolutely. Well, and again, if you have more to share, feel free to go ahead. If not, we can do open discussion.
Well, basically, my question, about Hutchison effect, to Dr. Hoyer is that as a physicist, as an engineer yourself, how do you qualify Hutchison effect in one viewpoint, which can in this one, or non-subjective? What is it? What makes it?
Oh, Harold, you're cutting out again, sir.
Could you write your question? In
Yeah,
the
Harold,
chat?
could you write the question and I'll ask it for you, sir? Oh, there he goes. Okay, it looks like he's typing. Yeah, I wonder if the issue might be Wi-Fi connection, because it seems like he has pretty good connection a lot of the time. Okay, and then John had asked if your approach deals with the problems of Kaluza-Klein 5D unification that led to the development of string theory. John, do you want to ask that just verbally or?
Thank you. I've been fascinated lately with gravito-electromagnetism, particularly the gravitational B field, some authors have called it. And in a cosmological paper that was published in the last couple of years, some have derived this effect from the frame dragging effect in general relativity. To me, this offers a possible kind of high road to unification physics between gravity and electromagnetism, much akin to your hypotheses here, and the original 5D Kaluza-Klein unification attempts. But I've forgotten, since it's been years since I read on Kaluza-Klein, I've forgotten what the problem was. I guess it just skipped over the nuclear forces. And so I'm wondering, what were those problems, and do you address those? Or are you working in the hope that they may not be as important in the presence of some of the emerging phenomena with things like gravitomagnetism? And I know that that's very different than Hutchison and very different than diamagnetism, but there's a kind of continuum of relational effects between gravity and magnetism, and it seems like the nuclear force is left out. There are some results on unification, obviously coming in superstrings. There's also perhaps more idiosyncratic. There's a proprietary theory on unification from the MITRE group, some folks in here might be familiar with, that purports to be able to access gravity from the weak nuclear force. But my thinking now, reading on the deep connections between gravitation and electromagnetism, is that these are the high scale forces. I'm coming from a background in pure mathematics in fractal geometry. And this is related in to many different areas of analysis, such as topological data analysis in computer science. And what they're doing is analyzing data at larger and smaller scales, similar to like the Kolmogorov turbulence cascade. And you may have changes of dimension. It's a lot akin to renormalization. And in this light, it could be that at larger scales of organization, we have unified E&M and gravity. Then at smaller scales of organization, those forces are largely irrelevant, and we worry about the nuclear forces. Obviously, electromagnetism is still very important at the subatomic scale, but gravity goes out the window. But that's kind of the kind of thought I've been having lately. So sorry to just trying to paint some background to my original question. Could it be that we could even have a clean derivation of, if not E&M, but GEM at least, from just GR, or within the context of, say, 5-dimensional Kaluza-Klein theory.
Kaluza theory is here pure classical theory. It's not a quantum theory. And to the time of Kaluza, the quantum theory was, there were more success. And that's the reason for the Kaluza-Klein theory with a compactified 5th dimension. And it led to the string theory, which we see here on the slide. I hope you see it. With the upper left corner of gravity and electromagnetism and the scalar field where the question mark is. And this is a long range force with inverse square law. And the other are locally confined. Weak interaction and strong interaction. And unification of electromagnetism and weak interaction was successful in quantum theory. And the strongest classical connection is between gravity and electromagnetism. So this is again a shearing of the theories which we can't put together. And I follow only the classical version of 5D theory.
Now, Detlef, if I could jump in really quick, and actually let me mute Chris. Okay, if I could jump in really quick, I did a series of interviews and spoke at length with John Deering, who is a laser physicist. He worked with James Coram, Dr. James Coram, and this was an area that he had some interest in as well. He was interested in as well, Kaluza-Klein, applied string and brane theory, those things. He also knew a little bit about the Hutchison effect. One of the things that John had mentioned repeatedly, and he had mentioned this in the context of like the Nazi bell that Nick Cook described, as well as several other experiments. Poglanov's force beam generator had some anomalies that it generated. One of the things that what was the phrase he said? He said, you have to remember that when you're modifying time space, if you pull the cat's tail, you get the whole cat. And what he meant by that was a lot of these experiments appear to show like molecular breakdowns. The Hutchison effect itself shows molecular breakdowns. Also, some of them show what appears to be like transmutation of elements or some, nuclear decay, dangerous byproducts, radiation, things like that. If you're modifying time space, would you expect to see those things in addition to something like a levitation effect? Would you expect to see disruptions in the strong and weak force, things along those lines?
Oh, it was very surprising for me to see the Hutchison effect, which I didn't know since the end of last year. More known as the Biefeld-Brown effect.
Well, I think, and if I could clarify, the reason that I mentioned that is, so what John had somewhat described, I hope I'm repeating this correctly, was if you can imagine like a molecule, right? Whatever molecule, of a metal or a plastic or something like that, and it's sitting in space-time. I think what he was trying to describe was if you were folding space-time, if you're able to fold the manifold of space-time, you're going to have molecules, atoms, all sorts of structures that are caught in that fold. And so in theory, right, like normally with a molecule you have fractions of a micron between the atoms in it. But if you're able to bend that manifold, then all of a sudden maybe the atoms can't see each other to stay connected. you know, or maybe if that manifold, if that falls across the atom itself, maybe the atom breaks down, maybe it decays into smaller parts, you know. So I think that was what he was describing. He was saying that in a lot of these experiments, you do see like you'll see some radioactive byproducts, you'll see, you know, molecular disruptions, all sorts of stuff. So I don't know. I mean, in your thought though, with your expertise, does that make sense? Is that something you would probably look for, or do you think it's not a relevant issue?
Yes, if the gravity constant changes or the inertia changes, then the orbits would change because it's a canceling of the centrifugal force and electric force, which makes the orbit stable. And if we change the inertia, so also the orbits would change. But if we take again the expanding universe, so there also the space cell itself is widening. So dust particles would get greater distances. But in this example, there are pennies on the balloon, and they don't get bigger or smaller. They stay as they are. Although the space is widening, they may feel the Hubble drag because of the expanding universe, but the electromagnetic forces are so strong that the crystal structure remains stable. Also, the space underneath is widening. So it's different if the expansion is stronger than the electromagnetic force, or there's an event horizon across the atom or something else. So it depends on the energy scale, I think. And the expansion of the universe has not so much energy. Hutchison effect has also not much energy, only for over resonance effects perhaps, but I don't know. With low energy, I would expect such effects. But if you have enough energy to fold space-time, then the atoms may be broken.
Well, thank you. And again, because we've had a few new people enter the conference here, Option Y on Mac or Alt Y on Windows to raise your hand and ask a question. Dr. Detlef Hoyer has been talking about a hypothesis for the Hutchison effect in 5D Kaluza-Klein space. Option Y on Mac, Alt Y on Windows, or you can chat those questions out and we will pick them up in chat. And I think Harold actually had a question in chat. He said, what makes the Hutchison effect interesting to you as a scientist? Detlef, do you have any thoughts on that? I guess, what is the most interesting part of the Hutchison effect for you?
It's the lifting, or as I said, the push along table, and it's a force we don't know yet, because it's not electric, it's not magnetic, it's not diamagnetic, it's unknown, and there might be maybe this force is real. And there has to be in our known physics somewhere a loophole where this physics for this force hides. And I try to find it. Also, this may be the key to the UAP propulsion, which is very remarkable velocities. And it should be clear whether this is real, especially because of the abduction stories. And perhaps this is all not real, then we would need such a force for asteroid deflection to keep us safe from meteors and asteroids.
Yeah, that makes total sense. Let me see. And Robert just entered the room. And again, anybody else who has questions? John had a question. He was wondering if you could address the possibility of a cosmological big rip that seems to come from observational cosmology. That's not something that I'm.
Yes.
Oh.
Yes, it's the Robertson-Walker-Friedman-Lemaitre model of the Einstein equation, which has also the cosmological constant. And we had the slide where I said that there is a energy conservation for the gravitational level and the rate of expansion of the universe. And it depends on the total energy of the expansion. If it's small, then the expansion will come to zero, and the universe again falls into the one center point. If the energy has a critical value, then the expansion goes on forever, but stops in infinity. And this model has always Euclidean geometry, so the curvature is zero. And we seem to have a universe where the energy is greater than the critical energy, so it expands hyperbolically and will expand forever. And in the velocity of the expansion will increase. So sometime it will points in the universe which are far away have much more greater escape or velocity. The Hubble constant is 75 kilometers per second, kilometers per second for 1 megaparsec. So this is the velocity in which the Andromeda galaxy flies away from us. And the bigger the distance is, desto greater is the velocity. So for very great distances, it reaches the light velocity, and there is an event horizon. And if the velocity increases, then this event horizon comes nearer and nearer. And sometime it will approach Earth, and sometime it will approach the atoms, and that is a big rip. So I thought the question was, what is a big rip? It was no connection to the fifth dimension in the question, I think.
Wonderful. Well, thank you so much. Oh, yeah, John, do you want to go again, sir?
Thank you so much for indulging me here. You had the metric with little l squared over big L squared. And perhaps this can actually prove the stability on the atomic scale. You know, I think Einstein, I think the you know, I think the big rip does follow from some reasonable assumptions, but I think Einstein would turn over in his grave, and it seems like an extreme conclusion that even quarks would not be stable under the expansion of space-time. And if you look at that term in that metric, I'm not looking at the slide, so I'm going from memory, but you have that little L in the numerator. So as we zoom in, that little L is getting small. And in that scenario of cosmic accelerated expansion, that big L is getting big in the denominator. And that's taking the local metric on small L scales to 0, is it not? And maybe your derivation here actually shows the stability of space-time on local scales, which is fitting of kind of a classically inspired theory. I think that would be very laudable if that holds out, but I'm probably biased looking at it and thinking kind of anti-big rip.
Okay. No, that's actually my research or understanding these equations in the book. And in the book, this equation is used to derive the geodesic motion, which then has a fifth force in addition to the other forces. And I can't answer that, whether this is a contribution to the stability or not of atoms. I'm sorry. Oh, you're muted.
Oh, John, you are. Oh, okay. Yeah, he's muted himself out there. Okay, and let me see. There's Kim Beresford just joined, and that may be Kevin as well. Let me see. So yeah, it's 1:56. We've got about 4 minutes left. If anybody has any final questions for, Robert, sir.
More questions.
Oh, actually, let me take Robert first because he hasn't asked a question yet.
Okay.
Hi. Detlef, is that how you pronounce your name?
Yes.
I have just opened your file that you've went over. Page number 22, you showed the extrinsic, intrinsic cosmological constant, that curve from the simulation of the Earth going to deep space.
Yeah.
Of E potential to radius. Is that a true hyperbolic curve?
Just a moment, I show it to the.
It might be a stupid question, but I was just curious.
Just a moment.
I haven't reviewed my math for a while.
This picture, you mean?
Yes, exactly.
Yeah. If the escape velocity for Earth is 11.2 kilometers per second, and if the velocity is smaller, then we get an orbit with an ellipse or circle in different with different radius. If the velocity of the body is exactly the escape velocity, the trajectory is parabolic and ends in infinity. It's not closing as an ellipse. And if the velocity is higher, then it has a hyperbolic trajectory. And here the electromagnetic potential is also hyperbola with 1/r. Yes, it's hyperbolic. The gravitational potential itself is also hyperbolic.
Okay. I was just curious about
this
that.
is similar to the critical energy of the universe. It's like the escape velocity.
Okay.
And if it's smaller, it comes back, and if it's bigger, it escapes. And
So the horizontal line's the asymptote.
yes,
Okay,
Or-
representing 0 joules?
yes, yes.
Okay, all right,
And
thank you.
The gravitational energy is negative, and the kinetic energy positive.
All right, okay.
Yep.
Thank you.
There was a
Awesome.
question, Harold.
Okay, well, thank you. Yeah, thank you, Robert. So yeah, it is 1:59 now. So I think that we are just about all set. So let me do this. Again, what I want to do is I want to put this back on gallery mode here, and everyone, you know what? Let me mute this out. Okay, mute. Oops. Here, I'll just do mute all. Okay, and everyone, please put your hands together for Detlef Hoyer. Again, remarkable presentation. Detlef, thank you so much for returning to APEC and for presenting on this. This is wonderful material. It's truly an honor to have had you here. Okay, so what I want to do now is, oh, absolutely, sir, absolutely. So our next guest is, and we have Kim here. I have a feeling that this is actually Kevin using her Zoom login. So I'm going to ask to unmute. Let me start with an intro though first. I want to start with an introduction.